Okay, so I titled this video a tricky one. In the book they call it a complex one, but I didn't want to use the word complex because I didn't want you to think of complex numbers. But anyway, it says to expand this logarithmic expression, and it's log base 6. Okay, so I want to think of that 64. 64, if you break it down to its primes, you're going to get 2 to the 6th. So just on your side paper, you can do that. That's going to make this easier to do. And it really isn't all that tricky, I don't think, but we'll see. So I'm going to replace the 64 with 2 to the 6th. So there it is. Make sure I got everything. Okay, so what we want to do is we want to identify factors, bases. So you have a 2 to the 6th power, x to the 3rd power. Then you've got that factor, 4x plus 1. And then you have this factor down in the denominator, 2x minus 1. Well, all of them get their own logarithm, and the ones in the numerator will be addition, the ones in the denominator will be subtraction. So I'm going to write this log base 6, and they're all base 6, and you have to put the base 6, otherwise it will look like a common log. I'm going to put parentheses. I forgot I was going to put parentheses. So these are all the ones in the numerator. And then we just have one factor in the denominator, but it gets subtracted. Now, a couple things. You have to have the parentheses on those binomials. That's not an option. I probably should have mentioned that before. But you have to keep that as all one expression. Remember, you can't split up the addition and subtraction in the logarithm, in the argument. Okay? So you just have one more thing to do, and that's bring any exponent that's not 1, bring that down. So I'm going to have 6 log base 6 of 2 plus 3 log base 6 of x plus log base 6 of quantity 4x plus 1. Quantity meaning I need those parentheses, minus log base 6 of quantity 2x minus 1. And that is long, but that's the answer. Okay, it was a fun one.